When we learn something for the first time, we need books of tutorial fashion, such as OpenGL Superbible 7th edition, also OpenGL Programming Guide 9th edition. These books are written tutorial fashion. When we learn OpenGL for the first time, we can use books of tutorial fashion. But tutorials are tutorials. Through tutorial books, we can learn the basics or fundamentals of OpenGL. Once you learn basics or fundamentals of OpenGL, you can jump to the latest version of OpenGL. From this web page, you can download OpenGL 4.6 Core Profile Specification. This is about 851 pages long. Now download it. 851 pages might look very big for most people, but if you have fundamental understanding of OpenGL, then reading this book is piece of cake or a breeze in the hot summer season. Go back. We also need OpenGL shading language, the latest specification. This book is very short, only 238 pages. Also download. These PDFs are much better than any other resources. For example, press Ctrl F, search for built-in, click Next. Then you can find in Chapter 7 built-in variables, in Chapter 8 built-in functions, for example, built-in language variables. This is Vertex shader special variables, built-in variables. This documentation gives all the details about these built-in variables. Also, special variables. Click Next. Then tessellation control special variables. Also click Next. Then tessellation evaluation shader special variables. Also geometric shader special variables. Fragment shader special variables. These are the best documentation about OpenGL shader language. I learned up-to-date CUDA programming reading official CUDA documentation. In the same manner, I learned latest C++ reading ISO C++ latest working drafts. In this episode, we will learn OpenGL multiple buffers using OpenGL Superbible 7th edition. From this book, Part 1, Chapter 5, Buffers, Feeding Vertex Shaders from Buffer. If you scroll down, you can find this part of the code. We will learn how to use GL Vertex Array, Vertex Buffer, GL Vertex Array, attribute binding. These functions will be using multiple OpenGL buffers for position and color. We use 2 buffers in this episode. Hello, hi, Future Thomas. Today is October 5th, 2022. This is 4th episode for C++ 17 2023 CUDA SQL OpenGL DBB. This is also 4th episode about OpenGL Buffer. 12th episode OpenGL Superbible 7. We will learn how to use multiple vertex buffers. Also, we will be use offset of macro. This session continues from my previous episode, episode 93, OpenGL Buffer 3. double-click this link. This video is now for members only. Only members can access to this video. More, download current video source code. Double-click it. Show in folder, unzip it. Folder name 094. I would change the folder name multiple buffers. Copy, paste it to my working directory. From this folder, we will rename multiple buffers like this. Double click it. We created this code in our previous episode. Set as startup project. From this file, open MapBuffer. I created this source code in the previous episode, episode 93, OpenGL Buffer 3. Now press Ctrl F5. It should build and run successfully. Now close it. Ctrl End. In this function, I made simple mistake. It should be vertex count. GL size I vertex count. Cut, paste. We use two elements for each vertex, so we have to divide by 2. Then pass vertex count. Press Ctrl F5. It should build and run successfully as before. Now close it. Close it. Now close this file. Right-click the solution, add new project, OpenGL Superbible7. Click Next. Click Create. Fold it up, right-click, set as startup project. Press Ctrl F5. It should build and run successfully. Now close it. Close it. Shader files. Add new item. Select utility text file. Points.but. Click Add. Right-click, add new item. Make sure utility text file selected. Points flag. So we added two shader file. Vertex shader. Version 450 core. Copy, paste. This is fragment shader. Now in the vertex shader, I will use out layout location 0 in vector 3 position layout location 1 in vec 3 color out vec 4 vs color. Please note that input color is vec 3, output color is vec 4. Now copy this paste it here. It should be input, out, back4, color. For the main, this fragment shader is very simple. This is output color, vs color, this is input. Save all. Now we can close this fragment shader. For the main, we need to set GL position. It does not work because assignment of incompatible types. This GL position is of type back4. Position is of type back3. So we need typecast back4. We can set 1.0f vs color. This is output color. This is back4. So back4, we can use input. We set alpha channel 1.0f. This is alpha channel. This is W component of back4. Save all. Open up source.cpp. Arrange side by side. I will auto hide. Arrange like this. In the startup, we need to compile the shaders. This program, create program, points, Vertex, copy, paste, flag, don't miss semicolon. Of course, we have to define program. We will create a private section here. GL name T program. We initialize with the default value. We will declare GL name T Vertex array object. GL name T Vertex array buffer. Now we create two elements. Initialize with 0. We are now using multiple buffer object. I changed the name. Now scroll up. GL use program. This program. Check GL operation. This is step 1. Now press Ctrl F5. It should build and run successfully. I would say step 0. If we make a syntax error, for example, copy, paste, we happen to specify wrong syntax. Press Ctrl F5. You should have this message, step 0, invalid operation. Now close it. Correct it. Like this. While watching my current video, I assume you are reading OpenGL Superbible 7th edition. From Part 1, Chapter 5 Data, I assume you have read Chapter 5 up to Feeding Vertex Shader from Buffers. In this book, Feeding Vertex Shader from Buffers, if you scroll down, you can find in page 152 listing 5.7. This is listing 5.7 using multiple separate vertex attributes. I assume you have read up to this part of the book, listing 5.7, multiple separate vertex attributes. We will define some plots, GL plot center 0.0 F, GL plot left negative 0.7 F, right 0.7 F, copy, paste, bottom, top. So we defined these values: static, GL, plot, positions, this is plural, 3, semicolon. Now left, bottom, 0.0 F. This is our first vertex. Copy, paste, right, bottom, copy, paste. This is center, top. Remove trailing comma. We will simply copy and paste. Now it is colors. So we defined two arrays. This array will be used for vertex positions. This color will be used for vertex colors. Now GL create vertex arrays. 1. This vertex array object. GL enable vertex array attribute. This vertex array object. Index. What is this index? This index stands for this location. So 0. I would say check GL operation. Step 1. Copy, paste. Step 2. So we created vertex arrays, then enabled vertex array attribute by passing vertex array and the vertex array attribute position, its location is 0. We associated vertex array. This vertex array is attribute 0. This attribute position location 0. Now GL create buffers. We create 2 buffers by passing this vertex buffer object. Check GL operation. Step 3. Please understand that vertex buffer object, this is defined to be array with 2 elements. So we are creating 2 buffers. Now GL name the buffer storage buffer. So we use first buffer. This is first buffer. Then size. This is byte count. Size over. We use position. Then data. Data is position. Then flags. We use default flag. Check GL operation. Step 4. Press Ctrl F5. It should build and run successfully. Now close it. Here GL vertex array vertex buffer. The first is vertex array object. Please pay attention to pop-up window. This vertex array object. Then binding index. What the hell is binding index? This binding index is 0. You will soon see what binding index means. Then buffer. This vertex buffer object. We are using first vertex buffer object. Index 0. We used vertex buffer object 0, 0. Then offset. We use offset 0. Then stride. We need to specify the byte count of a vertex. 1, 2, 3 elements of a plot. So the stride should be size of GL plot 3 elements. This stands for stride over each vertex or byte count of each vertex. GL plot 3. This is check GL operation step 5. Now GL vertex array attribute format. The first is vertex array object. This vertex array object. Then follows attribute index. Please understand vertex array attribute. So this means vertex position is attribute. Its index is 0. So we pass 0. Then size. This size means how many elements in the vertex. We have 1, 2, 3 elements. So 3. I will make a line break here. Then type GL plot, because each element of vertex is of type GL plot. Now Boolean normalized GL false relative offset. In this case, there is only one array. We don't need to specify offset. Offset is simply 0 in this case. Now this is step 6. We need GL vertex array attribute binding. The first comes vertex array object. This vertex array object. Then attribute index. We associate attribute index. This is position attribute. So 0. 0. Binding index. This is binding index. So 0. Check GL operation step 7. Now GL enable Vertex array attribute. The first is Vertex array object. This Vertex array object. The second is index. This vertex positions. This is attribute. Its index is 0. So 0. Check GL operation step 8. Now press Ctrl F7. F7 means build. Successful. Up to this point, we specified position for attribute position. Now we specify buffer for color. So for attribute color, scroll up, you can say for attribute position. Scroll down. We have to enable this attribute like this. GL enable Vertex array attribute. The first is this Vertex array object index means this index semicolon. I will make it smaller. This is check GL operation step 9. I will demarcate like this to make it look outstanding. Now here again, GL named buffer storage. Buffer. This Vertex buffer object. Now we pass 1 because 1 is for color. Then size of colors. So we are specifying this data. We initialize first buffer index 1, then colors bit flag 0. This is step 10. Then GL Vertex array Vertex buffer. Vertex array object. This Vertex array object. Then binding index. We consumed here 0, for binding index for buffer object 0. Now we use 1, then buffer, this vertex buffer object 1, offset means the size of each element of a color. So it is glplot 3 byte count. It should be size of glplot 3. Offset is 0. The memory is consecutive. In this case, memory is consecutive, so the offset is 0 and the stride is this. I made a mistake here. Check GL operation step 11. Now GL vertex array attribute format. The first is vertex array object. This vertex array object. Then attribute index. We are setting color attribute. Its index is 1. So 1. Then size. This size means how many elements in one color. So it should be 3. Then type glplot normalized glpulse relative offset 0. Check GL operation step 12. We have to find GL vertex array attribute finding vertex array object. This vertex array object. Then attribute index. This attribute index is 1. So 1. Binding index. This index is a binding index 1. Check GL operation step 13. Now GL enable vertex array attribute. The first is vertex array object. This vertex array object. Index. This index means colors location. So it should be 1. Never forget find the vertex array or GL find the vertex array. GL find vertex array. This vertex array object. This step is super important. Check GL operation. Step 14. Final step. Now press Ctrl F7. It should build. Now scroll down. In the render, GL draw arrays, GL triangles 0, 3. Now press Ctrl F5. Close it. I don't like the color. Here 5. Ctrl F5. Okay, it's better.